Okay, so up to this point, Monday you should have turned in problems 1 through 8. Yesterday was 9 through 12. Today we're going to do 13 to 17. We are going to do all of 13, 14 to 17. There's going to be some things you'll do by yourself, but let's take a look at problem 13. Now, problem 13 says to perform the operations and then simplify. So I just want to go through these because they are fractions, and that tends to be something that many students struggle with. So I think this is a good one to kind of do together. For problem A and B, those are multiplication or division of fractions. We don't have to have a common denominator. But problem C and D, those are ones we are going to have to get a common denominator. So they're a little different. Okay. So let's first focus on A and B. Now for problem A, I would suggest anything that has more than one term, put it in parentheses. Okay. And then the rule of thumb is if it's a multiplication and there's a common factor on the top and the bottom, get rid of it. Divide that factor off. So you'll notice we have an x minus 6, which is a perfect match. Now we also have a 4 and a 16. Those are both divisible by 4. So if we divide them both by 4, we're left with a 1 and a 4. Now you can multiply then simplify, but I suggest simplify and then multiply. Now remember, to multiply fractions, just multiply tops with tops and bottoms with bottoms. The only thing left on top, because we've canceled out the 4 and the x minus 6, is a 1. So sometimes I like to just make sure I have a 1 written somewhere to remind me, hey, there's still going to be a 1 there. On the bottom, we are left with a 4 and an x minus 1. You can keep those separated, or you can actually physically multiply them. I don't care. If you take calculus in the future, many times keeping the denominator separated is a good idea. Simplifying the top is something that's the one we have to simplify. The bottom, I think keeping them separated is a good idea. Now let's talk about B. Now A is a multiplication, B is a division. So there's a few different things that we need to think about for B. The first thing we're going to do, again, let's use our parentheses. We're going to turn it into a multiplication. To divide by a fraction is the same as multiplying by its reciprocal. So let's just make this 9y minus 36 over 7y plus 21 times 3y plus 9 over 4 minus y. Okay. Now, in order for us to do what we did in part A was in factored form. We have to get B in factored form to get things to simplify nicely. So let's factor that as much as possible. Our first numerator, 9y minus 36, both of those pieces are divisible by 9. 7y plus 21, both of those pieces are divisible by 7. Let's do the same thing for our second fraction. Our top numerator, both pieces are divisible by 3. And then our bottom is, it's fine the way that it looks. Now we're looking for common factors that we can reduce. So some things that I notice are the y plus 3s are perfect matches. Get rid of those. Okay. Now be careful about the y minus 4. The y minus 4 are not perfect matches. If you have a changed subtraction, if the order is different, they're actually opposites. Look, in one, the y is positive and the other is y is negative. In one, the 4 is negative, but the other, the 4 is positive. They're exact opposites. So you're allowed to cancel them as long as when you cancel them, you do have to leave a -1 behind because they are opposites. So they don't cancel out just perfectly like we would want. You do leave a -1 behind. Now, the numerical components, on top we have a 9 and a 3. Those are not divisible by 7. So, yeah, we're kind of done. So on top, all of our algebraic components have canceled. We are left with a -1 times 9 times 3. Let's just call that a -27. And then 7 times 1, or just a 7, is left in our denominator. Algebraically, mixed numbers are of no use to us unless maybe we're graphing. So I don't ever expect you to go to a mixed number. So just -27 over 7 is a reduced version. Perfect, great, leave it. Okay. So multiplication and division of fractions tends to always be a little bit easier than addition and subtraction like we see in C and D. So let's start with C. Put your 9 over 1. And what do we have to have if we're adding or subtracting fractions? Yes. The same denominator, that common denominator. So put any pieces that are not just one term in parentheses. Our denominators contain a 1 and an x plus 6. So the only thing we need is an x plus 6. So we're going to multiply this fraction on top and bottom by an x plus 6. Okay. So our first fraction is 9 times x plus 6. Our second fraction's numerator is just that 8. And the rule of fractions is that if you get a common denominator, you keep the denominator, and we can add up the numerators. Now let's take the 9 and distribute it. We'll kind of do this in one step so that it just makes it a little easier. This would be 9 times x and 9 times 6, and then that plus 8 there. And then the only thing we can do is combine like terms. 54 plus 8 is 62. Now, in order to tell if your fraction is reduced as far as possible, you should look to see, is there a way to factor, and is there a factor in common? 9 and 62 have no common factors. 62 is 2 times 31, so it doesn't have anything in common with the 9. So that's your answer. You cannot cancel out pieces and parts of a sum like that. So it's just 9x plus 2 over x plus 6 is our final answer. Okay. Now we're going to do a similar technique for D, but I do need a little bit of room. So what I did for C, I'm going to kind of scooch over a little bit. But we're going to start out the same way. We're going to surround these by parentheses. And I'm going to write them over here, and I'm going to leave a little space next to them because we need a little space to accomplish what we need. Okay. So I kind of think of it as kind of flip-flopping denominators. The left denominator has 8x plus 1 that the other one needs, and the other denominator has x plus 8 that the first one needs. So just kind of flip-flop. So this one we're going to multiply by an x plus 8 on top and bottom. This one we're going to multiply by an 8x plus 1 on top and bottom. So you kind of just flip-flop denominators, and you have to just multiply by top and bottom. So our denominator, again, like I was saying, if you were in a calculus class, I don't usually have you multiply out those denominators. It doesn't help, unless there may be conjugates or something. But if they're just 8x plus 1 and x plus 8, just leave it. Just leave it. But we do want to see if the top simplifies in any sort of manner that's helpful to us. So let's take the 5 and distribute it. Let's take the negative x, attach that negative with the x, and let's distribute it. Okay, so when we do that, we get 5x plus 40. We get negative 8x squared minus x. Okay. Now, let's put that in descending order. And we get negative 8x squared plus 4x plus 40, and all over 8x plus 1 and x plus 8. Now, we really don't know if this is in simplified form until we look to see if our numerator is factorable in such a way that is helpful to us. I noticed that all of my numerators pieces, all those terms are divisible by 4. And to fix the fact we have a negative in front, can we please, let's take out a negative 4. It will make things go a little nicer. So if I divide all of that by negative 4, okay, I'm going to get a 2x squared minus x minus 10. And then you need to ask myself, is that a factorable quantity? Well, 2 times 10 is 20. 20 is 5 times 4, which has a difference of 1. So it is a factorable quantity. If you were to factor it, to get that 4 and 5 action happening, you would need a minus 2 back here and a plus 5 back there. So if you did slide and divide and you did all that process, that's what you get. Now, at this point, and only at this point, if we had a factor on top that matched a factor on the bottom, would we do something about it? Now that we see all the factors, there is no numerical component of 4 that we can cancel out. There's not a 2x plus 5 that matches anything, or x minus 2, or any of those pieces. So that is our final answer. Okay. So fractions are fun. You know how that goes. They don't go anywhere. We will, in trigonometry, fractions come up in different ways than in the pre-calc semester, but nothing that you guys will have any issues with. Okay. Do we have any questions about 13 before we move on? Good. Okay. So now let's talk about 14. Now, 14, 15, 16, and 17 are all going to rely on graphing. So if you want a piece of graph paper from the back table, feel free to grab a sheet of graph paper, take a picture, but you can make a little rough sketch on the side of your paper. I'm okay with that. Okay. So for 14, just make a little Cartesian plane. You need about 7 pieces going up and down, left and right, and then everything will fit for A. So all they want you to do is plot the points. I'm going to do the first one to show you exactly what I'm looking for. They say that point A is negative 5, 3. So go to negative 5, 3, put your dot, and please put a little A next to it. So that's all you're doing for 14A. Please plot the 3 points that you see, point A, B, and C. Now, I would like to talk about 14B, okay? So 14B says, find the equation of the line in the form y equals mx plus b that passes through points A and B, okay? So I would like to talk about what I want you to do for that. The first step you always take when doing that method to find the equation of a line between 2 points. The first thing you find is your slope. So you're going to do y2 minus y1 over x2 minus x1. So hopefully you know how to do that. And you're going to have it drawn so you can really use that as a guide as well. The second thing you're going to do is you're going to use the equation, the point slope formula equation of a line. So that's y minus y1 equals m times x minus x1. And then the third thing you're going to do is solve for y. Okay. So to accomplish B, let me remind you again what you want to do. You want to find the slope between the lines. You do have it graphed. You can find the slope using the graph or using the formula y2 minus y1 over x2 minus x1. After you have found your slope, please use the point slope formula to set up the equation of the line. And once you plop the junk in, then we move on to step 3. You just solve it for y, and then you have what they need for b. Okay, so that's what you want to do for step B. Do we have any questions about 14? Okay, so find the slope, plug it into the point slope formula, solve for y, you're done. Okay. Now for 15, let me show you what you're looking for, and that will kind of tell you what 15, 16 are the same. So we'll do most of 15 together, and then it's your job to finish 16. So again, we need a graph, a little graph here. So just make a graph. So for 15's chart, the first 3 are giving you x values to plug in. The last 2 are giving you y values to plug in. And then you're just going to list the points. So let me show you what I'm talking about. If you plug -1 into our equation, y equals -2x plus 7. That would be -2 times -1, which is 2, plus 7, which is 9. And then you just write here -1. And feel free to go over to the graph paper you created, -1, 9, put it on the page. If you plug in 0, you get 7. So that's the 0.07. That is your y-intercept. When graphing a line, I always graph the y-intercept. So I would definitely put that on our graph paper. To plug in 1, -2 times 1 is -2 plus 7 is 5. So that's the 0.15. And that can fit on our graph paper too. Let's keep going. Now, the last 2 on your graph are a little more difficult, but not horrible to do. We are setting the y value equal to 3 and solving it. So if you subtract 7 for both sides, you get -4. Divide that by -2. -4 divided by -2 is 2. And we should see that 2, 3 lines up perfectly with the things we've already graphed because it's a linear equation. So that's how you can check your algebra. If it doesn't give you a line, you did something wrong. And then in the last one here, we're setting y equal to 0. That's actually giving us our x-intercept. It's always a good point to plug in. So where does y equal -2x plus 7? If you were to solve that, you get -7 divided by -2, and actually getting like 3.5, getting an actual decimal value when you're graphing. That's one time where the decimal value is very helpful. Otherwise, I would have just put 7 over 2. But since I need to graph it anyway, why not? So you'll see that we hit the y-axis here. And that should line up in a perfect straight line. Now, obviously, I made my graph, I did not use the straight line maker or anything pretty. So don't expect it to be beautiful and great. But so that's how you complete the table. And that's how you graph. It should be a linear equation. That is exactly what you need to do, please, for problem 16 as well. Okay. And then finally, I want to talk about problem number 17. Let's talk about problem 17. It says to find the x-intercept and y-intercepts and sketch the graph. To find an x and y-intercept of a linear equation, I always use what I call the 0, 0 chart. Let x equal 0. That's going to be your y-intercept. Let y equal 0. That's going to be our x-intercept. So just plug those values in, and you'll find what you need. Okay. Now let's talk about this top one right here. If I let x equal 0, I get 0 plus y equals 1, so y is equal to 1. Now when an equation of a line is in standard form like that, 5x plus y equals 1, it's always a good idea to do the 0, 0 chart anyway. The intercept chart is really helpful because it's so nice to plug those values in. Now, if I let y equal 1, I get 5x equals 1, or x equals 1/5. And then let's sketch the graph. I'm going to make 1 pretty big because we have to go all the way to 1/5. So the point 0, 1 is our y-intercept. There you go. The point 1/5, 0 is our x-intercept. I'll assume, I'll just make a sketch as to where I think 1/5 hits. And why not? That seems pretty good. And then it's a line, so please connect it with a line. Okay. So that is problems 13 to 17. Please, by the end of class, I want you to have turned in 13 to 17. Please remember, if you check up on the board, you have some assignments that you need to turn in that will go on the third 9 weeks. Did you turn in the 6A notes? Did you turn in the 6A homework, the 6B homework, the December Achieve? Monday, you should have turned in 1 through 8, yesterday 9 through 12, and today, please make sure you're turning in 13 to 17 before the end of class. So you have the remainder of class to finish these up and finish any of the other things you need to on the board. There you go.